In this problem, we have to solve for integer values. So that is integral solutions. So the problem is a square plus ab plus b square is equals to 21. So you see, you have two unknowns, a and b are unknowns, and you have one equation. And the condition is given, that is the solutions are integer. So a and b both are integer, that is given. How you will solve this problem? So let us try to solve this. First I will take this 21 to the left hand side, then I can write my equation a square plus ab, or in fact I can write ba plus b square minus 21, this is equals to 0. Or I can rearrange a square plus b times a plus b square minus 21, this is equals to 0. Now this is a quadratic equation in a. So this is a square and then you have a. So this is a quadratic equation in a. If you have a quadratic equation, something like ax square plus bx plus c is equals to 0, the solution of this equation is given by this term, minus b plus minus b square minus 4ac, and this divided by 2a. So if I use this formula, I can find solution of this equation. So let us find. So in this case, b is basically b. So solution or root becomes b is b and plus minus b square minus 4, and in this case a is 1, 4a, and in this case c is b square minus 21. So this is b square minus 21. And this divided by 2 times 1. So this is the solution. That is, let us simplify a little bit. Minus b plus minus, this will be b square minus 4b square. Basically there is no need to simplify. Let us keep as it is. 4 times b square minus 21 divided by 2. So this is the root of this equation. That is this equation. Now let us see what are the conclusion I can draw from this root. It is given that roots are integer. Of course, these are real root. This means the discriminant, that is the term inside the root, that is this term. This term should be greater than 0. So first condition I will have, that is discriminant should be greater than equal to 0. This means b square minus 4 times b square minus 21, this should be greater than equal to 0. Now see, these are the basically roots for a. So this is the value of a. Now a is integer. This means if a is integer and it is also given that b is integer, this means we should have a perfect square here. So this thing should be come out of the square root. So we can say this should be a perfect square. That is this term, the term inside the root. So I can say this term b square minus 4 times b square minus 21 is, this should be perfect square. Perfect square. Then only it can come outside the root. Not only perfect square, this also should be natural number. This will be more clear if you take this to this side. So what will happen if you take this to this side? So this will become 2a is equals to minus b plus minus a square root of b square minus 4 b square minus 21. Now see, This is an integer, so if you multiply by 2, this is an integer. And b is an integer. So this means this also has to be integer. And then this is also a perfect square. This means this is a natural number. So the third thing I can say, that is, this is b square minus 4 times b square minus 21 belongs to natural number set. So this belongs to natural number set. So this is a natural number. So with these three conditions, I can say that this term, that is the root, or in fact inside the root, this term, the term that is inside the square root, that is this term, can be written as m square. So what conclusion we are making? With these three conditions, I can say that this term, that is b square minus 4 times b square minus 21, can be written as m square, because it is a perfect square and it is also a natural number. So this will be m square, where m belongs to natural number set. So n is basically a natural number. So this n is a natural number. Now let us expand a little bit. So we will have b square minus 4b square, and this is plus 84 is equals to m square. Now I can say this is b square minus 4b square, this is minus 3b square plus 84 is equals to m square, or I can say m square plus 3b square is equals to 84. Now see this equation. In this equation, this number is multiplied by 3. So this means this is divisible by 3. So this is divisible by 3. You understand? So this is divisible by 3. And 84 can be written as 3 into 28. This means this number also divisible by 3. This means this has a factor of 3. This also has a factor of 3. This means m square should also have a factor of 3. So this suggests that I can write m is equals to 3k, where k is a natural number. So in this case, k is a natural number. So k belongs to natural number set. So now let us replace this with k is equals to m is equals to 3k. So now I can write this expression becomes m is equals to 3k. So 3k whole square plus 3b whole square is equals to 3 into 28. So this becomes 9k square plus 3b square is equals to 3 into 28. Let us cancel 3 throughout. So this will be 3k square plus b square, and this is equals to 28. Now you see the term b square, a square of something. This term is greater than equal to 0. B square will always be greater than 0 because this is a positive term. So this means now I can say, what can I say about 3k square? So 3k square will be less than equal to 28, because if you are adding some positive number in 3k square, then it becomes 28. This means 3k square itself is smaller than 28. That's why I have 3k square and then I'm adding something, then it becomes 28. So if I do not add something that is a positive number, then this number, that is 3k square, will be less than 28. So this is a consequence of the fact that b square is greater than equal to 0. So from here I can say that k square should be less than or equal to 28 by 3, that is 9 point something, but k is a natural number. You see, k is a natural number, so this should be less than 9. So this means what are the possible value for k? K is 0, 1, 2 and 3. Now we can consider these cases and we can find the value of a and b. So let us consider the first case. In this case you have k is equals to 0. So if k is equals to 0, what will be the value of b? If you remember, we have expression, that is this expression, that is 3k square plus b square is equals to 28. This means if k is equals to 0, b square is 28. This means b is the square root of 28. But b is an integer. So this is not a possible solution. B has to be an integer. Now let us consider case 2. So in case 2, you can have k is equals to 1. So if k is equals to 1, you will have 3 into 1 square, which is 3, plus b square is equals to 28. So this means from here b is equals to plus minus, because 28 minus 3 25, and if you take a square root, then this becomes plus minus 5. And once you know the value of b, you can calculate value of a using this equation. So let us use this to calculate value of a. So in this case a is equals to minus b, and if you take, so you can consider two cases when b is equals to 5 and then b is equals to minus 5. So case 1, or you can simply say when b is equals to 5. So this is the case when we are considering b is equals to 5. So in this case this will be minus 5 plus minus b square is 25 minus 4 times b square is 25 minus 21 divided by 2. So this value is minus 5 plus minus, this will be 25 minus, this is 4 into 4 16 divided by 2. So you will have minus 5 plus minus 9, a square root of 9 is 3 divided by 2. So this will be, one solution is minus 8 by 2 and another solution is minus 2 by 2. So this means you will have minus 4 and minus 1. Now if you take b is equals to minus 5, so what will happen? B is equals to minus 5. In this case you again use the same equation, only change will come at this place. This will become minus of minus. So you see this equation here, this is minus b, so minus of minus will become plus b, so this will be plus 5 and rest of the thing will remain as it is. So this will be plus 5 plus minus, this is, and you know this is 3 and this divided by 2, so this will be 8 by 2, one solution, and another solution is simply 2 by 2. So this is 4 and 1, so you will have two solutions, in this case 4 and 1. So for this case, that is k is equals to 1, how many solutions we have? We have solution pair a, b. So we have, when b is equals to 5, so b is equals to 5, then a value minus 4 minus 1. So this is one pair and this is another pair, minus 1 and 5. And when b is equals to minus 5, that is b is equals to minus 5, then we have two solutions, that is 1 and 4. So from this case, basically we got 4 pairs of solution. So these are the 4 pairs of solution that we have. So this is for case 2, that is k is equals to 1. Now you can do on your own how many solutions we will get when you have k is equals to 2 and k is equals to 3. So this is as a homework, you have to solve on your own. For k is equals to 3, what is the value of a and what is the value of b? And similarly for k is equals to 4, what is the value of a and what is the value of b? So let us discuss this in the comment box. I hope you enjoyed this video, and if you enjoy, please like this video, share with your friends and subscribe to my channel. I will see you in the next video. Thank you.